Good afternoon, everybody. My name is Michael Businger. I'm with Bernie McDonnell.
And I'm Ramon Bireg, but I'm with SBS.
So we're going to do a joint presentation today on Civil 3D and the integration with P4A.
All right, so I'll take over here for just a little bit, kind of breeze through these slides because you all know this information already. But at SBS, we work in the utilities and telecom environment, provide software and services to help our customers implement our software. This is a little bit out of date. We're a gold partner with Esri now and a platinum partner with Autodesk as well, and build our software on top of Autodesk products. We'll breeze through that one as well. A little bit about me, kind of how I got to be here in front of you today. My education and experience, I'm an electrical engineer. Started off at a utility doing PNC stuff in hydro generation as well as substations. Then moved to a consulting firm and then moved to SBS just about 2 years ago. I've been using the SDS suite of products since about 2016. And I'm a licensed PE in Washington State. You can see here that I like to be a little bit goofy and lighthearted, and I don't think having fun and doing good work are mutually exclusive. So like to have fun and do great work at the same time. Also, I'm a musician and I like to snowboard. So just a little bit about me there.
Again, Michael Businger, education backgrounds in computer aided drafting and design, a bachelor's from the University of Central Missouri. After that, I started working at Black & Veatch for 6 years. Did a little bit of physical and civil design there, led a small group, and then in 2017 moved to Burns & McDonnell, where I just actually celebrated 6 years there. Did everything from facility enhancement projects, substation designs, both domestically and internationally. And I'm now the assistant department manager of our civil structural design technology group. I've also taught at our local community college for 5 years, AutoCAD, MicroStation, and developed their course for Civil 3D. The SDSIC Civil Structural Committee co-chair. And then again, my experience is both in substation, civil and physical. These are my kids, love to make fun of me. They called me into the room and found out they drew on their own beards and glasses. We love to travel around. We got a little travel trailer we take all over the country. And then I am a huge motorcycle buff. That one is the only one I have now, but it is an animal. The presentation outline for today, we're going to go over some objectives next, and then we'll get into the scenarios and workflows, civil design workflow, concurrent design between the civil and the physical group. We'll get into Armand's design workflow, and then the use of external referencing in order to remain up to date on potential design changes. And then we can jump into questions if you have any. The objectives for today are going to be to learn the SDS physical for AutoCAD's adaptability relative to the Civil 3D surfaces, above grade and below grade adjustments. We'll learn how civil and physical design can be coordinated through SDS physical and AutoCAD, and also how to leverage the AutoCAD XREFs to assist with that cross-discipline coordination. So jumping into our scenarios and workflows. You're probably familiar with this if you've done civil designs, but it's always going to start with a survey request, geotech information, and then setting up the base file within Civil 3D. Geolocating it is, I think, the best way to go, but occasionally client standards make that a little difficult. External reference survey and station layouts, get those in there, and then reference any additional data as needed. We'll do pre-developed watershed analysis if necessary, research local data for permitting requirements, establishing top of steel or edge of pad. I've actually got a pretty slick way to do TOCs within Civil 3D, just underlaying the foundation plan now, but maybe for a different conference, we can get into that. Site grading designs, so substation pad, access roads, stormwater management. And then we'll do post-development watershed analysis and then stormwater calculations and modeling. So to jump into, I think, the bulk of this, so if we jump into the video here, We're going to be doing, we're going to grade the pad and the road. And to start, we've got an interior drive, the fence, and then there's an offset line in there. It's a little difficult to see, but we're going to use that in order to create the feature line. We'll end up selecting the feature line from the objects and then using that to set the elevations from the surface and change whatever we need to meet the design elevations. That's kind of what is getting worked through right now. And then next, we'll go into grading creation tools in order to create a group and then surface. And then we end up selecting feature lines and then make sure to tell that to grade the whole area within that feature line. And what we're going to do is do the pad first and then the roadway, and then in the end, we end up combining the surface models. So, checking everything here. Checking the layers here. We had to do a little bit of troubleshooting. The contour lines initially weren't showing up, so we had to go in and get that figured out. But ultimately, they popped in right there. Next, we get into creating an alignment for the road, utilizing the center line. And for naming conventions, we always try to keep things fairly, I think, obvious, just to make it easier to sort through things if needed. We'll get into creating a surface and a profile. The original one was the survey information. Sometimes the information that you get back from a surveyor is intelligent, sometimes it's not. Either way, you are able to create a surface off of it, though. It depends. But sometimes you just get the contour lines back, sometimes you'll get the point data. It varies. Try to be specific when requesting it. So now we're trying to set the, well, we did set the design contours, and then we're getting a visual representation for where that interior drive, the elevation of the access drive at the pad meets the roadway. So we're just getting an idea based off the stationing where that is. Then from there, we'll be able to use a little bit of the vertical curves and create some better profiles. And this video is sped up quite a bit, so it's definitely not this quick to do this. So doing some of this, we're utilizing the profile creation tools in order to create some of the profile data, and then using some of the geometry editor tools with the vertical curves. Once you get all this established, we typically will use generic assembly pieces within this program. We don't often do a lot of quantities of material for this type of scenario, but if you had a situation where you wanted to track that, you could build your own assemblies and get much more detailed information.
I noticed it's mostly lined up with polylines. Can you convert those polylines, or can you, like into, one of those curves, or do you have to draw that as a civil 3D?
I've never converted them.
Oh.
So I guess I don't have a definite answer for you. But here we're just creating that sub-assembly here. We'll use the properties in order to define a portion of it and create a crown just for the water shedding. And later on, if you do have changes to that, you can go back in and make that slope a little more, a little less, whatever your design requirements need, especially when tying in the two surfaces. If things aren't working out as well as the intended initially, you can go in and modify things a little later as well. But we've created a boundary, and now we have the two separate surfaces, one for the pad and one for the road. And for the roadway, it was important to create a boundary. That way the contours aren't running off into nothing. And then here we're creating alignments for the drive aprons. And then we'll end up adding those into corridor parameters.
Michael and I are sort of playing out a scenario here too, just showing how you can kind of coordinate between physical and civil. So in the background there, you'll see kind of starting physical design, while he's continually working on the civil design. And then, we're going to integrate these surfaces later into the P4A design in the upper right.
Currently on the civil side, I'm going back through and we're adjusting some grading before we end up combining these surfaces. And what we'll end up doing is making sure that the boundaries are turned on and then convert the 2D boundaries or the 3D boundaries into 2D boundaries. And then we'll go through the polyline there for the roadway and edit the line there with the removing vertices in order to get the boundaries to line up a little more seamlessly before we do that combination of surfaces. And at the same time, he's working on his side of the project as well. So.
Yeah, this one.
On the civil side, we're still editing that polyline just so the boundaries aren't overlapping. It just makes the combination a little more seamless whenever you do combine. Points along that path and then eliminate the final few to get that boundary more in line with the pad. It was polyline edit.
Oh.
Yeah.
No, that's the cool part about this is that like I am not dependent on you're a little bit dependent on like the layout of the station, right? So like the general layout, but that's I think what we both have in common with that. But I can take the civil 3D import at any time, versions of it. Yeah, if you're looking
as long as we've got a general arrangement, we can create the road spacing and fence spacing. He can get his clearances and everything. So we can lay out the majority of the site and then come in and do all this. Here we've skipped ahead a little bit, combined surfaces at this point, and then edited the pad as well. I think there were a couple of toolbars where we had opened up and made some edits to some grading, and now we're modifying the road elevation at this point in order to match some of those changes that had taken place from regrading that pad. And still, even at this point, you can adjust things as needed in order to meet requirements, depending on what type of, if you're using gravel or if you have an asphalt road, or what type of equipment you're bringing in on site will determine the slope of your road. So it's easily changeable. You can edit fairly quickly. I think the original video took roughly 37 minutes. So if you know your design parameters and you're familiar with what you're doing, you could fairly quickly, relatively quickly, put together a design. So making additional edits just because of what we had changed on the road required us to get a different boundary. So we're re-editing the boundary that was created, modifying just this assembly here just to show that it can be done fairly quickly. And then we'll redo that boundary, making them line up a little bit better. That way, whenever we do, we'll take both the files and paste them into one in order to do the combination, and then provide that to a physical counterpart. So it's going through and doing that, going edit and removing some of the unnecessary points again. This here could be. Yep, you can. You can take both the surfaces and paste them into one, and it'll combine them. And so here we edited the boundary based off of the modifications that we made to the roadway, and then edited the roadway elevations to meet the pad since that had changed. And then we come in and select both of the surfaces, put them into one, and then now you'll see in the viewer that rather than yeah, that's where you could merge them when the boundaries aren't as clean. It's just a little bit more seamless if you clean that up. This one. Start with the civil surface. Oh, yeah. So the drain part. Over here. Ooh, there you go. Back to the minute. Yeah, so those blue lines are the contours of the road alignment. So that's your roadway as part of the surface. Correct. So yep. So you have your road alignment as one, and that'll be its own surface, and then your pad will be its own surface as well. You need the elevations where the access roads inside the station meet that external alignment, so the roadway outside of the station. So where the roadway and the access drive meet, those two elevations need to be the same in order to make that work out. So the initial design that we did, there was a fairly steep grade, and then when we when we edited the site, we flattened it out a little bit more. But I mean, it'll be dependent on watershed and what you need, what kind of stormwater system you have in place. No, not always. I think you'll have at least like a 1.5% slope at a minimum. And then I think that the original design we did with this one, there was actually a detention pond on the other side of the road. But to shorten the example for this, we removed it and kind of simplified it a little bit. But every site will be a little different, have its own challenges, and will have different considerations. So I see what you're saying there. So yeah, you'll have your general arrangement plan, and then whenever it comes to like your foundations, you'll identify your steel height depending on what voltage class you're doing, right? It will determine your clearances and above roadway and everything else. So once you have that, you can kind of backtrack down steel heights to TOC, and then every client may have a different reveal that they're looking for whatever foundation type they may be using. So what we'll do is figure out where you want your bus height, figure out what the top of concrete will be from there, and then you can figure out your steel heights that are needed, and then make modifications if necessary. So the surface will help you with your top of concrete, and then your steel and everything will be built from there. Yeah, I think at this point we would have the general arrangement. You would have a good idea what your bus height was going to be, and then you can grade the pad as needed to meet any kind of stormwater requirements or anything else that you may need. If you have transformers on site and you need low buoys to bring those in, you're going to have a different elevation for your roadway than maybe if it was just a switching station or something. So it all kind of depends on the what you have going on that particular site. But at a minimum, as long as you have your bus height and you have the requirements to do the pad, you can grade the pad and then figure out your top of concrete based off of the bus height, and then figure out your structures from there.
All right, so that was sort of the physical half of things here, I'm sorry, that was the civil half of things here. Um, Looking at the P4A workflow, some of the stuff I was doing behind the scenes, you might have seen some of the annotations that were popping up in the upper right, but generally I was kind of going through the workflow that you see here, setting default values, setting up AUD elevation set. I was working over the site skeleton or the 2D station layout. In this case, it was an actual, 2D general arrangement drawing that was previously done. So I was just building 3D over that. Then I started placing features, and I went a little bit out of order in the sense of this general workflow. So I started placing features, and I ended up bringing in the Civil 3D surface later. Like I said, civil and physical designers can work totally in parallel with each other, without a lot of dependency, between themselves. And we could bring in the Civil 3D surface and adjust the P4A features at any point. What I'm going to show here is that I brought in the Civil 3D surface, about step 7 or something here. So I'm going to kind of show the back half of the video here. Oh, it's doing this weird thing with the mouse. That's annoying. Let's see. Sorry, there seems to be like a PowerPoint bug going on here. All right, so my first stop here is AUD elevation set. So you can see here that before I was working totally on the XY plane, and I brought in the Civil 3D surface that I got from Michael, and I'm adjusting all of the above grade design that I was doing down there on the XY plane. With AUD elevation set, it's 2 clicks of a button to take all of that content that I had previously worked on while Michael was working and bring it all up into the surface that I imported. So, obviously it doesn't bring the site layout itself because it's not a P4A feature, but all of that above grade design was brought in pretty much flawlessly. I could have done the, bus end connectors a little bit differently so they wouldn't have kind of sucked down to the surface over there on the right. Now I'm showing kind of the same thing with the below grade ground grid design. So I did a preliminary ground grid design, and typically this is below grade, and I'm going to bring it up to elevation at the surface. And this is a geolocated design, but the geolocation was slightly off. So you'll see here when we go into shaded mode, and you see the surface here that I'm actually a little bit kind of into the fence boundary with my substation design, but I wasn't. I was getting the point across, so I didn't really want to bother with adjusting the geolocation at the time. The point I'm trying to make here with the ground grid and the above grade features is that it's a couple clicks of a button, and it's it's the same whether your features are above grade or below grade. You're kind of running the same function, and the adjustments are the same. And so there's also 3 types of adjustments that we can do, I think, here relative to the surface. So obviously we can have things exactly on grade on the surface. We can have things at a relative offset to that surface, which is a really nice option. But we can also put things at an absolute value above or below the surface file as well. All right, so there goes the ground grid. So again, the same process too that I'm showing here can be repeated as well. If Michael sends me he has to upgrade the surface, and he sends me a different surface file, I turn this one off or delete it, bring in his new file, and then I can use the same command to make similar adjustments. Okay. So you see here, I'm a little bit off into the drainage there, but it's kind of it's pretty close within the fence lines here. But here I'm showing that everything is exactly on grade with the surface that Michael designed. And then you can see everything is following the contours. You can see there's a little bit of a dip in the ground grid, which we don't want, but we're going to correct that here in a second. But everything is following the exact contours of the Civil 3D surface. So after we do that, this is kind of the initial step. Now we can make some adjustments relative to the surface. So what I'm doing here is I'm selecting all of the ground grid connectors here, and I'm offsetting them relatively using the position Z attribute. So I did something like 6 feet just for dramatic effect, right? Like this is not a normal engineering value, but just so we can see it all very clearly below the surface. So I'm offsetting all of the ground grid connectors. Let's take a second since it's hundreds of features. So now I've got all the connectors here sitting below the surface. The next step, one of the concepts in P4A is that the linear geometry, follows its connected points geometrically. So I'm going to just, make a quick change, to a geometric attribute on the ground grid conductors. And this is like an attribute that doesn't matter because the lines are set to be modeled as straight anyway. But just making a quick change, we'll take all of those conductors and bring them down, back down to their connected points. So, the below grade crosses and T's, the ground grid connectors that we just moved down. Okay. So this is a relative adjustment, what I'm showing here. So, everything is, 6 feet below, the elevation from the surface right above it, right? So it's still, maintaining sort of the shape and curvature of the surface because it's a relative offset, right? So this is not really ideal for a ground grid, but this is just one type of adjustment that can be made. So again, I'm just showing this kind of to illustrate the example here. Right? And then again, the point is that, these types of adjustments are the same, whether, you're sort of working in the negative direction for below grade or the positive direction for above grade. Obviously you want the top of concrete all to be at, similar or the same elevation. So, I'm not really showing this stuff with the above grade features, but it's all the same. The next thing I'm going to show is, sort of how do we, take the ground grid and show it, all at an absolute elevation. Right. So for this, we use the Z attribute instead of the position Z attribute, and we just set the elevation to be whatever we like. In my mind, this is a little bit less accurate in terms of construction, I think, because if you think about how it's going to work in the real world, right, they're going to go to a point and then they're going to dig a certain amount of feet, right? So it's always a relative value from the point in which they're digging. It might be a little bit harder to get to an absolute elevation. Right, so just like with the relative adjustment, I adjusted the points first, and then I changed a little attribute and adjusted their connected conductors. And now we're all basically essentially on the 1,000-foot elevation plane, right? So the ground grid is now totally flat. We've lost sort of the contours and curvature of the surface there. It's all at the same elevation, which is typically how we design here. So, one of the great things about P4A is that both of these options are available to our users, however they want to see it, right? With a little bit of curvature, or if they want to see it totally flat because that's what they're used to. Both of these options are available. All right, one of the last things I want to show is just how you can use XREFs to kind of stay up to date with each other. So here I'm showing that you can actually compare the surfaces as well. So if Michael sent me an updated surface, I can actually look at the differences between that one and the last one he sent me. So that's what I'm showing here. In 2020 and newer, I believe in 2020 AutoCAD and newer, there's this great XREF compare function. So if you check the box down there in the bottom right, you can compare the changes. Hit pause on me. No, it's still going. And for those that don't know what XREF means, it stands for external reference. So here you can see I've obviously got some foundation problems here with the surface. We've started there a little bit with the site boundary. I'm getting the notification here about the XREF has changed recently. Hey, there's that drainage pond you were talking about, right? The original one. All right. So here I'm just in the normal AutoCAD XREF compare thing. So this is nothing really specific to P4A, but just showing as you're collaborating with your peers, how you can look at the differences between versions. If you're wondering kind of what was done or what wasn't done, wanting to review or any of those sorts of things. A lot of great functions and settings available there as well. That's about it. You can change all of these colors. You can show rev clouds. A lot of really great functionality. Currently provided by Autodesk.